Yesterday we talked populations and we got all the way to this slide where we were talking about the two different types of population growth, which is what we started with this morning. There is something called exponential growth, and then there is something called logistic growth. And depending on what kind of species you are, you follow one of the two types of population growth patterns. All right, ladies and gentlemen, this is exponential growth. Exponential growth stays the same as the population size increases steadily. This model shows what we call a J shaped curve. And this shows the steady increase of the population size. So, ladies and gentlemen, this is kind of like that example that I just showed you with your job with Elon Musk. Okay, started off really slow, really slow, really slow, barely moving, barely moving, barely moving. But at some point, those doubling effect really start to take shape, and it causes the population, in this case, in the case of the Elon Musk example, the money, to really start growing really fast. If you have a population growing like this, think about this as if imagine if every single person you knew grew up and had, kind of like they did in the old days, like 10 kids. And then each of those 10 kids grow up and they have 10 kids. And each of those 10 kids grow up and they have 10 kids. Within like 3 generations, that one individual will be responsible for creating 110 individuals. That's a lot of growth. And presumably we're going to say it like in a like 50-year span for humans. Okay? Big explosion, exponential growth. So, what can lead to exponential growth, or maybe what doesn't lead to exponential growth? Let's take a quick look. So, what if the population size keeps growing and growing and growing? Ladies and gentlemen, this is what's currently happening with the human population on planet Earth. And what a lot of people are afraid of is that we might be reaching our carrying capacity. So, what the carrying capacity, symbolized by the letter K, is the population size that an environment can sustain. So, what factors contribute to an environment's carrying capacity? The amount of food available, the amount of space available, the amount of, I guess, clean environment, like that's not polluted, um, so that there's not disease and stuff like that. Maybe the amounts of mates, food, water, cleanliness, less disease, mates available. All of these things are going to contribute to an environment's carrying capacity. How many organisms can that environment sustain? How many can it hold? Okay. So the most important of which are probably food and water and shelter, because those every single living organism needs food, water, and shelter. And then there's other things added to that again as well. Issues or questions? Again, carrying capacity tells us the number of organisms that an environment can sustain. And like I said, a lot of scientists are worried because the human population keeps increasing. Scientists are worried that maybe the Earth is reaching its carrying capacity for humans because we're starting to see some of the negative effects of having, quote, overpopulation. Because when you have too many, there's just not enough resources. Oops, went too far. So overpopulation can lead to, one second, guys, I have a visitor. Pardon me? Oh, yes. 1 second, guys. Sorry about that, guys. I had to sign a card for one of my colleagues. All right, so overpopulation. So, what is overpopulation? If I go over my carrying capacity, then I say that there is overpopulation. So, what does overpopulate? What is the downside of overpopulation? Well, again, if the big things are food, water, and shelter,
which includes all the music composed by the Oil Mix team for the new Chasm era.
Amari, if we could mute, that would be lovely. Okay, so overpopulation again, not enough water. Overpopulation, not enough food. Overpopulation tends to lead to unhygienic conditions, which means that there is going to be a higher chance of diseases. Overpopulation will be a disturbance in the ecosystem, meaning there's not going to be enough shelter for everybody. So, ladies and gentlemen, and I'm not trying to be funny and I'm not trying to be doom and gloom, if you can see this, what you then can also see is that now you can see some of the evidence as to why it is that some scientists are worried that we are leading to the carrying capacity of the earth for humans. We've seen problems in our water supply. We have seen problems in the human population with starvation and malnutrition. We have seen problems in many countries and parts of our country about unhygienic living conditions, and we have seen a rise in infectious disease. I mean, we just had a pandemic over the last few years, which is the first major global pandemic in over 100 years. We have seen many disturbances in ecosystems. So, again, this is some of the evidence that leads scientists to believe that maybe we are getting close to, if not have already exceeded, the carrying capacity for the human population for planet Earth. Okay, so when we talk about these limiting factors, a limiting factor is anything that is going to be able to limit or cap the number of individuals in a population. There are two types of limiting factors. There is the density dependent limiting factor, and there is the density independent limiting factor. Density dependent limiting factors depend on the population density. We talked about population density yesterday. Population density is about how many individuals live in a space. So, those individuals living in that space are using resources. Those resources become our density dependent resources because they depend on the number of individuals. So, for example, food, water, shelter, diseases are density dependent. Because if I have a cold and I'm in my room by myself because I have a very, very spread out distribution, I'm not going to get anybody else sick. Any density dependent factor is going to limit the population size, and it has a greater effect usually if the population is more dense. Issues or questions? Okay, this is our logistic growth path. Uh, It is sometimes called an S curve. Now, you'd have to have really bad handwriting for that to be your S, but that's okay. If exponential is a J curve, then logistic growth is what we call an S curve. And this is a model of population growth considered to be the carrying capacity and limited by density dependent factors. So, what you can see is at the beginning, we have this exponential growth, but then my limiting factors kick in, and then I get this nice flat curve. Whenever you see the curve flattening out, what that tells you is those individuals have now reached the carrying capacity. The nice thing is if you see a nice flattened curve, that tells you that that population has become stable and is probably a pretty healthy population. So, what we like to see as population ecologists is our initial growth followed by a flat curve. That again, because that shows a healthy, well developing population. Again, and what this tells us is that the population has reached the carrying capacity of that environment. Issues or questions? All right, so one more time. Limiting factors are anything that can cause a population growth to decrease or to slow down. Now, again, we saw the density dependent limiting factors, those depend on the number of individuals in the area. Other limiting factors might include competition, predation, parasitism or disease, drought, extreme climates, human disturbances. The list can go on and on and on. There are lots of things that will be considered limiting factors. Okay, we also have what we call density independent factors. Density independent factors also help to control the size of a population, but it is completely independent of those individuals. Forest fires. It wouldn't matter if I had 10 deer in the forest or 1,000 deer in a forest. If a forest fire comes through, there's going to be a decrease in those deer population. Weather, climate, volcanic eruptions, earthquakes, tsunamis. For the most part, we like to say as scientists, if it's happening from nature, like if it's a weather event, if it's a global event, if it's an abiotic effect, it is a density independent factor. Remember, abiotic, non living. The weather isn't living, climate's not living, a volcano is not living, an earthquake, tsunami, etc. These are all non living abiotic factors in the environment. If it is an abiotic factor, it is density independent. These are just things that happen in nature that sometimes can limit populations. So, for example, if there is an extreme drought, you're going to see a lot of populations go down because there's just not enough water. If there is a huge volcanic eruption, you're going to see populations go down because, lava is bad and so is volcanic ash, and it Lava is really hot and it burns and kills things. Volcanic ash can cover an area and create such horrible air pollution. And actually, to the point where it can even block out the sun in some cases if it's bad enough. So, again, this can cause a reduction in population size, but it's considered completely random. Like these are things that just happen, and it does not matter what the actual individual population size is or isn't, has no effect. There are two types of organisms when it comes to growth patterns. We have the R strategists and the K strategists. The R strategists always follow growth that is exponential. Exponential growth when the environment is right, and it results in temporarily large populations. Think of the video that we watched the other day with the Ed puzzle. They were talking about this with those mosquitoes in Texas. The environmental conditions were perfect, and they had an explosion in the population of mosquitoes in Texas. I want to say it was 2012 or 13, somewhere in there. These tend to be animals, these tend to be organisms that can reproduce 20, 30, 100, 1,000, 2,000, 10,000 at a time. For example, those female mosquitoes, they were laying up to 2,000 eggs in a 2-week period. When certain fish lay eggs, they're going to literally lay 100 to 500 eggs every time they lay eggs. They reproduce in very, very large quantities when the conditions are correct. And that creates a boom in their explosion. It creates that J curve where you see the population going up and up and up and up and up and up and up. The other type, I'm sorry, are there any issues or questions before I move on? Okay. The other form of strategist is what we call a K strategist. A K strategist are organisms that grow slowly. Their populations are usually small, and they keep pretty much near the carrying capacity of their environment. K strategists have usually very long lifespans. They have a slow maturing process, and they have reproduction later in life. K strategists will always follow the S-shaped curve. They have a gradual increase and then they taper off. Versus the R strategists, they just explode and then there's a crash, and that's never a good thing. All right, are there any issues or questions on exponential growth, logistic growth, density dependent, density independent limiting factors, R strategists, or K strategists? Okay, that's what we have talked about today.